Hi there, folks. Today we're looking at variables and real number operations. So let's start with defining a variable. A variable is just a symbol. Usually we use a letter. It really just represents an unknown. It's essentially the equivalent of having a blank space inside of our expression. All right, so instead of actually writing a blank, like a fill in the blank, we put a variable in its place. We put a letter that represents some unknown value. And today what we're going to be doing mostly with variables is figuring out, okay, if we know that this variable is represented by this value, I can plug that value in and then simplify the expression using numbers, okay? And when we talk about real number operations, we're really just talking about order of operations, okay? So two things we're going to look at today in terms of expressions, and really the difference between an expression and an equation. An equation has an equal sign, so expressions will never have equal signs, okay? So if there's no equal sign, it's an expression. An algebraic expression basically has variables in it, all right? So in other words, an algebraic expression when there are unknowns, all right? So we might have to plug values in for those unknowns before we can simplify that expression, all right? A numerical expression is basically one where there's no variables, it's all numbers, all right? And essentially what we're going to do with algebraic expressions today is we're going to convert them to numeric expressions. One of the places that this is done most often is when you're dealing with formulas, especially in science class, things like that. So formulas are basically equations that only have variables in them, but we plug numbers in to turn them into numerical types of expressions so that we can simplify, okay? Each variable represents something very specific. In things like science, they represent certain measurements, okay? So order of operations, let's start with that. Order of operations, I'm going to call it this thing IRMDAS. You may already know it by a different name, PEMDAS. If you go with PEMDAS, that is okay, but please write it in this fashion where the M and the D are written above one another, the A and the S are written above one another, okay? You've previously done PEMDAS, but PEMDAS is a little bit incomplete, and there's a little bit of confusion here, so I'm expanding it to IRMDAS to add a couple more things in here. First of all, the first thing we do in terms of order of operations, this is just telling us what to simplify and in what order to simplify it, okay? It's the directions that work us through numeric expressions, all right? So the directions say that I need to do inclusion symbols first. That's what the I stands for. And inclusion symbols are any symbols that kind of group things together. The classic example, the one we use the most often, is parentheses, okay? That's an example of inclusion symbols. But we also would include brackets in that category, or braces in that category, or absolute value is the one that people forget, the two lines on each side of the numbers, okay? So absolute value would also be inclusion symbols. So anything that puts things in groups are inclusion symbols. So it's not just parentheses, it's all those things that are like parentheses as well, okay? Next on the list, we have exponents. And the R stands for roots, like radical symbols, that kind of thing, all right? We're probably pretty familiar with exponents, and we understand what those are, like 2 to the third power, the 3 is an exponent. And what that tells me to do is to do 2 times itself 3 times, all right? Or 4 to the 5th power, that's saying, hey, 4 times itself 5 times, the 5 is the exponent, all right? But roots, we might not be as familiar with these. These are the things that look like this, like square roots. Okay, so if I had something like the square root of 4, that's a 2. It's the undoing of squaring something. We also have things like cube roots or fourth roots, that kind of stuff, all right? For our purposes in Algebra 1, we'll deal with roots from the perspective of pretty much just square roots. But I've kind of overlooked these before because this is not an operation we've done a lot of. We're going to do more of that operation this year, which is why I throw it into order of operations, okay? And the thing you should understand that between exponents and roots, they are tied in terms of order of operations, okay? Whenever there's a tie, the tiebreaker is you have to work left to right, all right? And that's one of the things that students a lot of times forget, especially when it comes to multiplication and division, addition and subtraction. So here, M is multiply, and D is divide. And a couple symbols for multiply here. We've got the times symbol that looks kind of like an X. We'll kind of shy away from that one moving forward. We'll use the little dot, which also means multiplication. All right. We'll also use this, where we basically write 2 things next to each other with just a parenthesis. When things are written side by side, it implies multiplication. Okay. For division, some of the symbols we'll use, there's the old-fashioned division symbol for long division, where we do that, and we have like a number inside and the number outside that says 9 divided by 3. We'll use this symbol. That's one of the ones we use. But now we'll also use things like a slash or even a fraction bar. A fraction bar is just a division symbol when we're dealing with numbers, okay? And again, multiplication and division are tied, and students always forget this one. They always think to do multiplication first, but multiplication and division are tied, and remember the tiebreaker is left to right. So if I have multiplication and division is farther left, I have to do the division first, okay? Multiplication, division are tied, the tiebreaker is left to right. And then addition and subtraction here. So this one means to add. The A stands for add, the S stands for subtract. And addition, we really only have the one sign. It's that addition sign. Subtraction, we only have one sign. It's the subtraction sign, okay? I should clarify over here. That's a fraction bar, all right, for division. So subtraction's that subtraction sign. And once again, addition and subtraction are tied, all right? Which means I have to go to the tiebreaker, which is left to right. Okay, so if I have addition and subtraction, but subtraction is further to the left, I have to do the subtraction first. Okay, that's the biggest mistake that students make with order of operations. All right, we have to follow order of operations. We have to do them in this order: inclusion symbols, then exponents and roots, then multiplication, division, then addition and subtraction. But be aware of the ties. Okay, exponents and roots are tied. Multiplication, division are tied. Addition and subtraction are tied. The tiebreaker is left to right. Okay. A nice way to remember this, I eat roasted marshmallow ducks after sunset. If you're a big fan of PEMDAS, we remember that one by Please Excuse My Dear Aunt Sally, and that one's fine as well, all right? But understand that those ties still exist and the tiebreaker is still the same, all right? And yeah, the I eat roasted marshmallow ducks after sunset is a little bit nonsensical, but so is Please Excuse My Dear Aunt Sally, unless you happen to have an Aunt Sally who's very rude. I don't know. I personally don't. So I eat roasted marshmallow ducks after sunset makes just as much sense to me. Okay? But again, make sure you include all of those different pieces. You understand that if you're using PEMDAS, it's not just parentheses, it's any of those groupings, and anything like parentheses. Okay? And again, make sure you understand the tiebreakers. For example, if I look at something like this guy, again, I start with inclusion symbols like parentheses. So I see a set of parentheses there, so I start with what's inside the parentheses. And inside the parentheses, I do the subtraction. And that's a 4. And here's the thing, if there's more than one operation inside the parentheses, I follow order of operations inside the parentheses, okay? And I start over and say, okay, let's go through inclusion symbols, then exponents, roots, then multiplication, division, then addition and subtraction, okay? So now I have an exponent. There's nothing left to do in the parentheses, so that step is done. I have an exponent. I have division, so I do the exponent next. 4 to the third power is a 64. And now I do the division. 64 divided by 2 is a 32. That's it. If I look at the next one, this one's a little bit tricky, and this is the other place. So we have trouble with tiebreakers, and then students have trouble recognizing invisible parentheses, all right? There are parentheses that are implied here, all right? And the parentheses for this one are around the numerator, okay? And I know there's parentheses there because that fraction bar, that division symbol, is happening to that entire numerator. And anytime I have an operation happening to an entire group of stuff, there are grouping symbols, there are inclusion symbols around that thing, okay? So watch out for those implied parentheses. Anytime an operation is happening to a bunch of stuff, it implies parentheses, okay? Other great examples would be like if I had the square root of like 3 plus 5. Notice that square root's happening to the entire 3 plus 5, so it's implied that there are parentheses there, okay? Anytime an operation is happening to more than one thing, those things are in parentheses, okay? So now following order of operations, I start with the parentheses. Inside the parentheses, I do the exponent first. That's a 16. I still have things to do inside those parentheses, so I do what's in those parentheses next, which is the subtraction. That's a 15. And now I can do the division, which is a 3. Okay? So again, watch out for the tiebreakers. Watch out for invisible parentheses. They will get you. Okay? If I look at this one again, I would start with parentheses here with inclusion symbols, but the only set of parentheses, there's only one value inside there. There's nothing else I can do inside those parentheses, so the parentheses are done. So now I go to exponents next. And notice I'm going to do one step at a time here. That's the best way to keep myself on track. 3 to the second power is a 9. And now I go to multiplication division. Notice there's multiplication and division listed here. See, the fact that there's no symbol written between the 4 and the 2 implies multiplication. And then I also have this division sign. And students a lot of times are tempted to do the multiplication first. But in this scenario, remember, multiplication and division are tied. So what's the tiebreaker? The tiebreaker is left to right. So which operation is farther to the left? The division is. So I have to do the division first, okay? So 16 divided by 4 is a 4. Now I can go ahead and do that multiplication, which is an 8. And now I have addition and subtraction. But again, those are tied. The tiebreaker is left to right. And yet this time it happens to be that the addition is farther to left. So I do the addition first. And now this one, 17 minus 27 is a negative 10. Okay? If I look at the next one, again, parentheses, there's no parentheses listed here, so I go on to exponents and roots. And notice I have an exponent here, 2 to the 6 to the second power, and I have a root, the square root of 9. Those are tied. I have to go left to right. So in this case, I would do the exponent first, which is a 36. But now that exponent's done, I can go ahead and I can do the root as well. The square root of 9 is a 3. Now I go to multiplication division. I see the multiplication at the back end of this thing. 2 times 3 is a 6. Now again, addition and subtraction are tied, so I have to use the tiebreaker left to right. So addition is farther left, so I add those. That's a 51. And then I subtract the 6, so that's a 45. Okay? But again, watch out for invisible parentheses. Watch out for those tiebreakers. Okay? If I look at this one, now I have an algebraic expression. The previous couple examples were numeric expressions. Now I have an algebraic expression because there's variables involved. Okay? But it tells me what those variables represent. And keep in mind, again, a variable is like a blank space, all right? And whenever I plug things in for a variable, I should always use parentheses to kind of show that blank space. In other words, here, x squared is really a blank space squared. Notice the use of parentheses. Plus x, that's like a blank space, minus 12, divided by y, which is like a blank space, and then squared. Always use parentheses to plug these things in because I want to make sure that whatever was happening to the x is happening to the entire number that I plug in for x, okay? And even though it doesn't make a huge difference here, it makes a big difference as soon as I start plugging in negative values. Things can change very quickly, okay? And I don't like that division sign. It wasn't very good. Let me try again. There we go. So now order of operations. Parentheses come first, but there's nothing to do inside the parentheses, so now I go to exponents and roots. So I can do the exponents. That's a 25. Here, 2 to the second power is a 4. Division comes next. And now addition and subtraction are tied. I have to go left to right. So I start at the left. I do the addition first this time. Again, that's only because it's farther to the left, and now I do the subtraction, and I'm done. Okay, so following order of operations. This one I've got a times b raised to the second power. Notice that's in parentheses, so that whole thing is raised to the second power. And here's the thing. If I had something like this and I started putting blank spaces in using parentheses, that looks a little messy. All right, this is where those other inclusion symbols, some of them come into play, like something like this. To kind of show which sets of parentheses goes with which, these bigger set, this outside set, I would typically use brackets for, okay? Brackets are literally the same thing as parentheses, but it helps us to kind of visually distinguish the different sets here, if that makes sense. But now I plug the 4 in, I plug the 2 in. Again, I start inside the parentheses or inside the brackets, and I have multiplication inside there, so I have to do the multiplication first because it's inside the inclusion symbols. So now I have 4 times 2, which is an 8. And I can leave these as brackets, or I can change it back to parentheses if I want, all right? But they're the same thing. 8 to the second power is a 64. and that's it. Okay? And then down here, writing these things, kind of just the terminology, refreshing ourselves on some of that. Quotient here in this first one, it says the quotient of a number n and 5. Remember, quotient is the solution we get from a division problem. So saying the quotient of something is telling me to divide. And since it says n and 5, that's going to be n divided by 5. Okay? And of course, I could write it using one of the other symbols. I could say n divided by 5 with the slash, or I could say something like n over 5 and do it like a fraction, because those are all division symbols, okay? So any one of these would be perfectly acceptable. The thing you have to make sure you're careful about is the order of these two things. Since it's the quotient of n and 5, it has to be n divided by 5. It can't be the other way around. Certain things you can switch around. It doesn't matter. Addition is one of them. Multiplication is the other. But division has to be in a certain order. Subtraction has to be in a certain order. So make sure you're aware of that. Okay? The next one, it says 3 more than twice a number and x. And notice there are two operations in a row. See, 3 more than is implying an addition problem, right? But then twice a number is implying a multiplication problem. And anytime you have an operation followed by another operation, we have to do the second one first. And here's why. It's saying 3 more than this other operation, which implies that that other operation has to happen before you can add the 3. Okay? So when it says 3 more than twice a number x, I have to figure out what twice a number x would look like first, which is just 2 times x or 2x. Now I want 3 more than that twice a number. Okay? And so just kind of think of that, because in situations in which we have to use parentheses, that's what's going to reveal it to us, okay? Is when we see an operation followed by another operation. For example, if I look at this guy, again, it says the product, see, so there's the product, that's multiplication, of 4 and the sum. See, so it's 4 and the sum, it's followed by another operation of addition. A number y and 2. Okay, so the product of 4 and the sum, I got a little carried away with my underlining here. So the product of 4 is implying the multiplication, but then sum is applying addition. So it's saying I want to multiply 4, but I want to multiply it by that addition problem. Okay, which means the addition has to happen first. So you have to do the sum of y and 2, that's y plus 2, and then I want to do 4 times that entire problem. That implies parentheses. See, it's 4 times the sum. I have to find a way for that sum to happen first, if that makes sense. Okay? And then the last one here, it says, what is the quotient of 5 and the sum? There it is again, 2 operations followed by one another. The quotient, that implies division. And then the quotient of 5 and the sum, which is addition. So it's implying that that sum has to happen, that addition has to happen before the quotient can happen, before I can divide by the 5. Okay? So it says, what is the quotient of 5 and the sum of 12 and a number x, if x is a negative 7? So that sum has to happen first. That's the number x and 12. Okay? And it says the quotient of 5 and that sum, and notice the order there, it's 5 divided by the x over 12. And notice there are implied parentheses here. If you want to slap parentheses around it, that would be fine also, okay? But then it goes a little bit further and says, hey, what's this going to be if I plug a negative 7 in? So once again, I plug a negative 7 in here for x. And now I simplify. Again, it's implied that there are parentheses around this whole thing because that operation is happening to that whole thing. That gives me a 5, and then 5 divided by 5 is a 1. Okay? So be super aware of that, especially if you see an operation followed by an operation, there might be some parentheses involved there. Okay? So again, order of operations, inclusion symbols, exponents and roots, multiplication, division, addition, and subtraction. Watch out for invisible parentheses. Watch out for those tiebreakers, okay? When you plug things in for variables, use parentheses to plug them in, all right? And then be aware of the wording of certain things in terms of the order and in terms of looking for where parentheses are going to go, okay?